Welcome to AceScape. This is your host Pronoy De, and here we are going to talk about XCB fluid mechanics. So now I guess you all have started or studied fluid mechanics in your old semester, like first semester or second semester, or someone else have on another semesters. But we all have fluid mechanics in our BTech degree. So now you all know that fluid is actually a very interesting subject. Alright. So now we will be dealing with fluid's properties, kinematics, dynamics, fluid in motion, fluid in rest, boundary layer theory, blah blah, whatever chapters we have. So now I have broken the fluid topics in few parts, and okay, so let's move to the content part. Let's see what we have. So in the content we have fluid and its properties as a first chapter. Now in fluid and its properties, let me tell you that fluid and its properties is actually a very interesting chapter, and it's a basic chapter, but from the GATE exam point of view, this chapter is very important. 2 or 3 marks every year will be coming from this topic. So now fluid at rest and relative rest, they have written, as I have mentioned, it is actually the static part. Static part. What happened to this? Okay. So now in the static part, the first chapter we have pressure and its measurement. Then we have vortex motion. Then we have hydrostatic forces. Then we have Bayesian function. Wait a minute. Let me switch to ball pen. Okay. So, slide. Okay. So here we have fluid in motion, as you all know, as a dynamics part. Here we have fluid dynamics and fluid kinematics. Fluid dynamics and fluid kinematics part are actually very important. As I have previously told that fluid and its properties are very important. 2 or 3 questions will be coming from fluid and its properties, and I am mentioning again that there will be questions in your paper from kinematics and dynamics. So now fluid through circular cross section. Here we have flow through pipes, laminar flow, turbulent flow. Here you will see different cases. For this particular chapter, laminar flow, turbulent flow, sorry, your properties chapter will be very important. In the properties chapter, you will learn crucial things, important things about laminar flow, particularly this chapter. Next slide, we have flow over plate, boundary layer theory, a very important chapter for you, for all the aspirants. Now we have dimensional analysis, RTT. This chapter is particularly very important. You will learn about linear momentum equations, angular momentum equations in the fluid dynamics part. But here in this chapter, you will see the mother equation. The cases you will have in the dynamics part, that is what I said, the laminar flow. RTT will be very important. Then you have dimensional analysis. So okay, I hope you will enjoy the class. So I will try my best. If you have any doubt, I will provide my number. You just send me a message or just give me a call. I will make sure that I will clear your doubts. So okay, now let's start then. Okay. So definition. Before going to the definition, first I want you to know what is the difference between fluid and solid. So for the basic difference, let's see. Let's assume This is a solid cross section, a solid body, solid cross section A and B. Now, if you give a minimum shear stress to this solid cross section, it will change its position like this, like this, like this, like this. Let's say after T time, it will be here in the position B dash. After T double dash time, it will be here B double dash. After T triple dash time, it will be here B triple dash. After this time, B will be here only. You have a pen in your hand. Let's see. Let's bend the pen a little bit. Give it some shear stress. You will see it will bend. But just that moment when you will remove the stress, the pen will be back at its own position. That is the property of solid. You can say that this angle is theta, this angle is theta 1, this angle is theta 2, this angle is theta 4, whatever you can say. So here we can see that the shear stress is directly proportional to d theta by dt. This angle is changing with time. Shear stress is directly proportional to d theta by dt. So now for the fluid part, you will definitely gonna have a glass of water in your house or a bottle of water, whatever. Open its cap and just throw a little bit of water in the ground or whatever. You will see, then give that little water a little bit of shear, give it a little stress. What happened? It will definitely this is A, this is B. It will definitely gonna change its position or its shape. But when you will remove that stress, it will never come back to its position, its previous position. So from here we know that fluid flows. It will never be back to its position. Fluid flows. This is the property of a fluid. So now you can write the definition. What you can write? Fluid is a substance which cannot resist any external shear force. Okay, so let me write it down for you. Okay, wait a minute. Okay, let's do this. Let's write the definition then. So let's write the definition. Fluid is a substance which cannot resist any external shear force. So I'm again repeating, fluid is a substance which cannot resist any external shear force. So now you guys have read fluid mechanics a little bit, I guess. Then you will definitely gonna have a doubt that said we have learned about viscoelastic fluid. What about it? Viscoelastic fluid will definitely gonna regain its original shape. So you know there is a very popular word called exception, I guess. So viscoelastic fluid is a exception. We are gonna talk about viscoelastic fluid definitely, but just let me write it. Okay, so now let's move to the properties part. Fluid properties. Starting with the property that is density. So what we know about density? Density is what? What is density? We represent density by rho. So we all know that density is equals to mass upon volume. So this is mass upon volume. So now, what is the unit of density? Density's unit is, you can write it as kg per meter cube mass by volume. Now for the dimension, we have m L power minus 3. So here is a very important point. You must write it down. This will give in the GATE exam. I guess the previous year they have given a question from this topic. I guess it's viscosity or density. Whatever. You have to write this point or write it down. The effect of temperature and pressure on density. So let's first talk about temperature. Density is equals to mass by volume. If I increase the temperature, definitely the mass will remain same and the volume will increase. Just think about it. You have a fluid element, you are increasing its pressure, its temperature, then definitely its volume is going to increase. So overall density increases. So what you have to remember, if I increase the temperature, density is going to decrease. Then let's go for the pressure part. Density is equals to mass by volume. Mass will remain same if I increase the pressure, but the volume is going to decrease. So overall, you can see that, right? Density is inversely proportional to volume. So the volume decreases. Density is obviously going to increase. So overall, the density is going to increase. So here you have to remember, when I increase the pressure, density is going to increase. I hope overall you understand the pressure and density, the effect of pressure and temperature on density. So now, in general, if anyone asks you, what is the density of water? What you guys are going to say? What's the density of water? Everybody says that density of water is what? 1000 kg per meter cube. But you are not going to say this. I don't think I'm going to say something different, but you have to say the proper density. And how to say it? You have to say that water will have 1000 kg per meter cube density when the pressure is 1 atm and at 4 degrees Celsius. Because you know, na, pressure and temperature, their effect is very much upon the density. And you will write some of the densities that is important, that is you are gonna deal with. Like if I say common densities, actually they kept it in a standard books. You will see this is 1 atm pressure and 20 degrees C. You can write it down, some of the densities, that is density of air, that is important, 1.205. Sometimes they are not going to provide, then you have to remember density of water. This is 998. You remember now? This is 4 and this is 20. That's why it's changing. kg per meter cube. Density of mercury. You remember this one? This is important. Sometimes they are not going to provide, then you write by yourself. Density of oil, 750 to 800 kg per meter cube. Okay, for the next property that we have, this is what we have. We have a specific volume. Specific volume is nothing. Nothing, it is just reciprocal of density. We represent it by V only. This is small v. So you can write it like this: volume by mass. This is volume. This is mass. So what will be the unit? This is meter cube per answer kg. Then we have specific weight. Specific weight is represented by W. I'm giving a star on this particular thing because this is going to help you. Specific weight is weight per volume. Remember this unit is a unit Newton per meter cube. Specific weight is equals to weight by volume. Right? We know weight is mg, and what we know m by v is density. Remember this. This is very important. It will help you when you want to solve the problems. It will help you. So now, what is the specific weight of water? If I ask you, what is the specific weight of water? What you have to write 1000 into 9.81. That is G. It's 9810 Newton per meter cube. And never forget, at 4 degrees C, 1 atm pressure. So, okay. Now we have another property, that is specific gravity. Facing a little bit of problem with this writing, whatever. This is presented by S. You can write a definition. We write the definition. Specific gravity is the ratio of density of fluid to the density of standard fluid. So if I write it a little bit mathematically, it will be like this. density of fluid, density of standard. This is 1000. Water is a standard fluid, considered as a standard fluid. Now, if we write it for mercury, what is the specific gravity of mercury? It will be divided by 1000. This is 13.6. Alright. Now there is another thing that is named as relative density. Relative density. There's a little bit of similarness between relative density and specific gravity. It is also be denoted by RD. RD is what? RD is same thing. This is ρ1 is the density. Let me consider ρ1 is the density of oil and this is the density of mercury. See, it will be what? It will be something like this: 800 divided by this. This is what relative density is. So you can write down a note. The note is every specific gravity is a relative density, but every relative density is not specific gravity. Alright, remember what is relative density and what is specific gravity. This is important, huh? This is important. In the problems, when you are going to solve problems, you are going to do a lot of things with this specific gravity, relative density. So now, there is something called cohesion and adhesion. What is cohesion? First of all, what is this cohesion? Cohesion is nothing but the attraction force between same molecules. And adhesion is the attraction force between different molecules. Let me just give you a little example here. Let's consider here we have some gas particles. Gas particles have random motion. They will move here and there like this. We have gas particles. So this is gas. See, they will move here and there. But there is still an attractive force between this. It's the same molecules, right? They have an attraction force. They have that cohesion. and here we have liquid. Let's consider here we have liquid. One water molecule will attract the another molecule. This is the cohesion. Now let's write one thing. You must write it down. On increasing temperature of liquid, cohesion decreases because intermolecular distance will increase. Just think about it. You have a liquid in a glass or whatever, in a pan. You are increasing the temperature. So definitely the intermolecular distance will increase. So what it will break? It will break the cohesion, the attractive force between the molecules. So you must remember this. This type of questions may came in the GATE exam. You can expect this type of questions because they have given viscosity, the effect of temperature in viscosity, then the effect of temperature in what I say density. So you can expect. So now you are thinking why sir is telling about this cohesion and adhesion. You will see in capillarity, surface tension. This is the major thing we have, brother. This is important. Remember, this is important. Cohesion and adhesion is very important. So I'm not going to write it down, but I'm going to definitely say you some observations about the cohesion and adhesion. You write it down. Cohesion enables a liquid to resist tensile load, while adhesion enables it to stick to another surface. So alright, now this is for the liquid. Now I'm going to discuss for gas. Now in case of gas, I told you that the molecules will have a random motion. So they have the cohesion definitely, but the attraction force is not that high. It is not that high. I can say it is negligible. There is almost no attraction between the molecules. So we can say that for gas, this cohesion is negligible. It's negligible. Now there is some observations. I'm not gonna write, but I'm gonna say you write it down. Cohesion enables a liquid to resist tensile load, while adhesion enables it to stick to another surface. You see now, water droplets stick to a glass plate or something, they stick to it. That is because of the adhesion. Adhesion only. Now, in the second point, in case of liquid, cohesion is dominating, but in case of gas, cohesion is negligible due to the random movement of molecules. What I have told, what I just told. Now, on increasing the temperature of liquid, randomness of liquid molecules increases, leading to decrease in cohesion. So now let's move. We have a thing that is called ideal fluid. Ideal. So what is ideal fluid? Ideal fluid actually is an imaginary fluid. It is an imaginary fluid. What is imaginary? What I mean by imaginary? I mean it is incompressible. I'm sorry. What's the rest? It is incompressible and having zero cohesion. This term is new for you, right? Incompressible. Incompressible means density is constant. Throughout, density is constant. You will know a lot of things about this term. Remember this term, huh? Remember this term. Incompressible.